Hello, my name's Matt Kepke. I'm the product manager for Eaton's medium voltage switchgear. Here at Eaton's Power Systems Experience Center in Warrendale, Pennsylvania, we're going to compare the construction standards and installation and design considerations between air insulated and gas insulated switchgear for medium voltage distribution applications. Electrical switchgear refers to a centralized collection of circuit breakers, fuses, and switches, circuit protection devices, that function to protect and control and isolate electrical equipment. The circuit protection devices are mounted in metal structures. A collection or one or more of these structures is called a switchgear lineup or assembly. The circuit protection devices distribute power to various sections of a facility and the electrical loads within those sections. They also provide protection to individuals and equipment throughout the facility by opening at a predetermined overcurrent level, thereby limiting the fault current carried by the system. Medium voltage switchgear ranges from 5 to 38,000 volts and is commonly found throughout electrical utility, transmission, and distribution systems, as well as medium to large size industrial and commercial facilities. Standards for electrical switchgear are defined by the IEEE organization in North America and the IEC organization in Europe and other parts of the world. Gas insulated switchgear, GIS, has sealed enclosures filled with an insulating gas, SF6, or an alternative gas. The gas-filled sealed enclosure facilitates a footprint reduction of up to 65% in some applications. The use of gas as an insulating medium when compared to similar air-insulated switchgear allows for the distance between the interrupting components to be reduced. The IEEE organization standard is C37.20.9 for GIS, and the IEC organization standard is 62271 for metal enclosed switchgear and control gear, which include GIS. Air insulated switchgear, AIS, is defined by the IEEE C37.20.2 standard for metal clad switchgear, and the IEEE C37.20.3 standard for metal enclosed switchgear. In metal clad switchgear, all electrical components, including the incoming bus, the outgoing bus, instrumentation, and main circuit breaker or switch, are enclosed in separate metal compartments to provide an additional level of safety and ruggedness. Metal-clad switchgear features draw-out circuit breakers for ease of maintenance and is often applied in industrial facilities and in electrical power generation and power transmission facilities. Metal enclosed switchgear contains circuit protection devices including circuit breakers, power fuses, and fusible switches, as well as control and metering equipment. These devices can be fixed mounted in common compartments and do not require the separate barriers or compartmentalization required in metal-clad switchgear. Metal enclosed switchgear is applied in commercial and many industrial facilities where the rugged construction of metal-clad may not be required. In medium voltage applications, selecting between AIS and GIS can be driven objectively by understanding the differences between the equipment. Today, the bulk of installed equipment is air-insulated switchgear, yet gas-insulated switchgear can provide advantages in certain applications. As we'll discuss, one main advantage of GIS is potential footprint savings. In order to determine the right equipment to apply, it is best to understand how the equipment is being designed, operated, and maintained. Looking to my left, you will see a lineup of air-insulated switchgear, and to my right, gas-insulated switchgear. As previously noted, one major difference between AIS and GIS is footprint. For the 5 to 38,000 volt GIS structure shown, the 1200 amp GIS structure is roughly 24 inches wide, and the 2000 or 2500 amp structure is roughly 31.5 inches wide. The 5 to 15 kV AIS switchgear here has a common width of 36 inches for all bus ratings. AIS switchgear at 38 kV is typically a single high construction and is at 42 inches wide. Comparing depth also allows for space savings, as GIS is roughly 71 inches deep for all voltage classes, but the AIS gear is 95 plus inches deep depending on the voltage class and rear compartment configurations. Understanding your application needs now and in the future can help drive equipment selection. For example, will you be using 120 volt AC or 125 volt DC for your control power? If your preference is to use a CPT installed in your switchgear lineup, AIS has the flexibility to provide a CPT mounted within the switchgear. However, GIS does not allow for auxiliary devices, such as CPTs, to be mounted internally. Control power for GIS, whether AC or DC, must be brought to the switchgear from a customer-supplied source. Voltage transformers, VTs, for metal-clad AIS must be mounted in withdrawable drawers to maintain construction standards. VTs for metal-enclosed GIS switchgear are fixed-mounted but can be removed or serviced as needed. Alternatives exist for traditional VTs. Resistive voltage dividers, which are not susceptible to transients or ferroresonance, can be used for sending 120-volt AC signals to relays or meters in your assembly to perform your essential protection and controls functions. We have discussed footprint and control power requirements. Now let's look further into installation requirements. Medium voltage AIS switchgear can have incoming voltage brought via cables or bus duct in the top, bottom, or side of the assembly. Whether your installation is in an integrated power assembly, over a cable vault, or installed on a concrete slab, an AIS lineup provides you with flexibility in your design. GIS switchgear is typically bottom entry for cabling into the lineup and does not allow for traditional bus duct to be used. While AIS presents more incoming and outgoing options for connections than GIS, GIS is front accessible and would allow the switchgear room to be decreased in size, not only by having a smaller footprint, but also by eliminating the need for rear access cable requirements. Looking at operations and maintenance features between AIS and GIS, there are differences in construction that can impact scheduled maintenance. Because AIS has components exposed to debris and the environment, more periodic maintenance activities are required to ensure proper operation of the assembly. Traditional methods include installing IR windows to check for hotspots on cable and bus connections that could be signs of loose connections and lead to an unplanned downtime event. Predictive maintenance solutions are also available for AIS that include partial discharge and continuous thermal monitoring. We will now look at an example of a continuous thermal monitoring solution. This solution calculates a delta T comparing ambient to bus bar temperature to determine system health. GIS, in contrast, does not require thermal scans due to all cable connections and bus bars being shielded and grounded, touch safe. Equipment, AIS or GIS, must be selected based on the equipment's ratings and capabilities to satisfy actual application requirements. GIS equipment offers a smaller footprint and space savings, but may have a high initial cost depending on the voltage class. However, GIS requires minimal maintenance compared to more regularly scheduled maintenance activities for AIS due to the vacuum interrupters being contained in SF6 or an alternative gas where they are not exposed to particulates and the environment for AIS. When future changes are expected in the lineup, including things like increasing a breaker size and adding auxiliary compartments and retrofitting to integral racking, AIS should be considered as it provides operational flexibility for modifications to the equipment cells. If you want to learn more about air-insulated switchgear and gas-insulated switchgear offerings and discuss your next medium voltage application, contact us or your local Eaton sales representative to schedule a visit to the Eaton Power Systems Experience Center.